Thank you. I'll be keeping the video on to the lecture so that you can also see me. And because today is the first lecture, I will give a couple of more minutes for all of the students to join. I'm very punctual generally for the lectures, so I will be starting the WebEx on time, or we will start the lectures on time, right? So today at 12 and then on Thursday at 8:30. So I request everyone to please also join on time because if you miss even 5-10 minutes of the lectures initially, it might be difficult for you to understand the remaining part, right? So please try to join on time. I will be providing the recorded, sessions that we do during every lecture. So in case if you have missed something or if you want to revisit certain topics, you will be able to do that. Okay, so let me get started. Let me first start the recording. Okay, and then I'll be sharing my screen. All right. So welcome everyone for the course on systems software, IT215, right? So just to give an introduction about myself and the course. So I'm Amit Mankori. I have been with the ICT for 5 years. I have total of 30 years of experience. Before joining the ICT, I was working in software industry for more than 25 years. So I have the IT industry background primarily for 25 years initially, but I have a passion of learning and teaching. So I joined academia about 6 years ago. So this particular course, system software, this is the first time I'm teaching this particular course to you guys, but a similar course of this one, I have been teaching to the other, PG students. So obviously the course content and everything is laid out properly, and I will be going through the material as mentioned here, right? So what is this course, right? I mean, what do we cover, and why do we need to learn this particular subject, right? So it's a system software is a core course for you guys, second year BTech student, ICT and CS programs. Usually we have 3 hours of lectures, but due to the online mode of teaching, we will be covering the material in 2.5 hours because we have the 2 lectures of 1 hour 15 minutes each. One is today 12 to 1:15. The other one we will have it on Thursday 8:30 to 9:45. Right. So we'll be covering the content in these 2 lectures through the week, and then there will be 3 hours of lab. Lab for you guys, right? So that will give you the practical aspect of the course. I strongly believe that any course, especially computer science or programming related courses, IT related courses, if you want to learn, the best way to learn is to implement the concepts yourself, right? So definitely, we as an instructor, we can tell you all about there is to learn in the course, and we can teach you, we can show you how things work. But generally speaking, you will be able to understand better if you implement those concepts yourself, right? So I know there is a tendency of taking help from other students, and it's fine. I don't mind collaboration or collaborative work, but copying is not going to get you anywhere, right? So if you want to understand the topics, if you want to understand the concepts, you have to put your brain around it, right? You have to try and implement certain aspects so that you learn. So what are the things that we will cover? So so this particular course requires you to know C programming in and out. Okay, because see, the course name is system software, and all of the system software that you may be aware of, for example, operating systems, right? So operating systems are usually, most of the operating systems are written in C or C++, right? So if you look at Windows, if you look at Unix, if you look at Ubuntu, Linux, whatever operating systems that you may be familiar with, even the Mac OS, Apple iOS, everything is written in C++. So that is why your understanding of C programming language, especially structures, pointers, file operations, and some of the pointer concepts like linked list and things like that will be very much useful here. The other aspect that if you know this, it will be helpful for the course, which is the computer organization course, which you had taken. The concept of operating system is what we will also need here, and the concept of computer networking also we will need here through the course. Now, I know that you have not gone through the official course on operating system and computer networks. So my goal through the covering of that material will be, I will be also covering the basic understanding of the operating system, like what is a process, right? What is a thread, right? How does the communication between different processes happen, and things like that, right? Then when we talk about networking, I will also talk about what are the different layers of networks and how does one computer communicates with another computer, right? So I will also give you some basic understanding on that. For example, I'll give you understanding on the TCP/IP protocol. So you may have heard about the name IP, or what we call Internet Protocol. You may have heard about something called as TCP, which is Transport Control Protocol. You may have heard about sockets. I'm not sure, but if you've heard about the terminology, but if you're not familiar with what exactly they are, I'll cover them, theoretically first, and then we will look at the implementation aspect, right? So the primary goal of this course is not only to learn the concepts theory, right? So all the concepts of operating systems, such as file handling, process controlling, inter-process communication, shell scripting, thread management, sockets, and all that. So we will learn those concepts theoretically, but then we will also use them through programming, through practical implementation in the program, right? These are the two textbooks that I recommend. But again, you feel free to use any textbooks that you may be familiar in this area, which maybe you like, and it's fine with that. And then this is the reference book that I sometimes refer to in some of the code that I provide. Okay. The assessment method is going to be this, where we will have the lab programming assignments. So there will be 10 to 12 labs, somewhere around there. Each lab, we will have the assignment for the topics that we have covered in the class, right? So I'll be covering the topics in the class, and for each of those topics that are covered in the class, we will have the lab assignments, right? Then we have midsem exam of 25% grade, end sem exam is 30% grade, and then from the middle of the semester, right? So somewhere in the middle of the semester, we will have the group-based project. So why why I have kept it starting from the middle of the semester? The reason being that currently you are not familiar with any of the concepts of the software systems, right? So you need to be able to really understand at least some of the topics before you can actually begin working on the project. So what we will do is that first half semester, we will not actually start on the project part. I'll give you the understanding of certain topics which are essential, right? And then once you have the understanding of the topic, then you start working on the project, somewhere from the middle of the semester. And this is going to be again a group project. So few students will work together. And how many, I'm not decided on that yet. But when the time comes, I will form the groups and I will let you know how many students will be working together. Okay, and this project will be evaluated towards the end of the semester through Viva or presentation, which will be accounting for 15% of your grade. Okay. Throughout the semester, I will also give you the quizzes. So basically, what the way I look at this quizzes is like we cover the content theoretically, right, and then your first implementation, first understanding of the practical aspect comes from the quizzes. Because what will happen is that whenever I'm covering the content, right, I'm not just going to cover the content theoretically. For every single concept that I cover in the course, as I mentioned, first I will give you the theoretical understanding, and then I will show you few snippets of code. Okay, so I have written small programs for every single concept that we will be learning, right? So every single concept will be explained through theory, and then I will provide you a small snippet of code which actually explains how that concept is really implemented in the programs. So once I cover those codes also in the lecture, you will have a better understanding how to implement that particular concept in your programs. And so based on that, I will give you the quizzes. Right? So quizzes will be similar to the code that we implement, that I've shown you in the lectures. And then if you're able to implement the quizzes, then you will know that you understood the topic practically and you know how to implement them. Then comes the lab assignment, right? So the lab assignment is like the next level. In the sense, in the lab assignment, what will happen is that one concept may have 2-3 sub concepts, right? And once you understand all those sub concepts, you will be implementing the programming assignment, the lab programming assignment, in the combination of those concepts. It may be possible that you have studied one concept, let's say last week, and then new concept was studied this week. Lab assignment may contain the assignment that may span across those 2 concepts or 3 concepts, like that, right? So basically what I'm trying to say is that quizzes is going to be a smaller versions of the code which you will implement in the lab assignments, because the quiz will generally contain only one topic, whereas the lab assignments may contain, it may span across multiple topics. Okay, so for quiz is that, and then you have the lab assignment, and then finally the third aspect of the practical assignment that you will do is the project. Now in the project, I'm expecting you to not only implement 1, 2, or 3 aspect, but all the aspects that we studied at least till the first half of the semester, right? So see, that is my point. I mean, you start with small, with the quizzes, then you try to build that using the programming assignment, and then finally you build to the project, right? So once you're able to implement, or you are able to take all the different concepts and try and able to implement all of them in a single piece of code or single piece of project, uh, that is the kind of expertise that you need to develop. If you are able to understand that, or if you are able to do that, then we can say that you have mastered the course, right? So what will be the course outcome? So the course outcome will be of two parts, right? So the first part, that first bullet point that I mentioned here, is primarily theoretical concepts. Okay, so you will be able to understand the Linux operating system commands, right? So I'm not sure how many of you had a chance to work on Unix-based operating system or Linux-based operating system. Obviously, we do use Android phones every day, but we use those as a user, right? We don't actually interact with the operating system directly, right? We don't actually use the operating system commands that are available to us. So that is something that we will be learning. I will also give you a basic understanding on the virtualization. So these days, as you know, that especially when you use cloud infrastructure, we use virtualization. It is used cloud. It is used in cloud very heavily, right? So what is a virtualization, and how do we use it? Well, the first important aspect is that when we use our computers, right? Our computers may have operating system which is probably not the operating system that we are going to use in our course. So in our course, we will be using Ubuntu operating system, right? So Unix was the operating system which was a base operating system on which the Linux operating system was built, right? And then on Linux, Ubuntu operating system. So Ubuntu is basically a flavor of Linux, and a Linux is a flavor of Unix, right? So we will be using Ubuntu operating system, but your computer, your laptop may be running a Windows or maybe Mac operating system, right? And so on. So we cannot directly install Ubuntu, as a host operating system. So what we will do, we will use a concept called virtualization, in which we will install first the Oracle Virtual Machine VirtualBox Manager, right? So VirtualBox is the product provided to us by Oracle, and we will be using this product, and we will be creating our own virtual machine inside the laptop. So we have our laptop, which is what we call host machine. In that host machine, we will be creating the virtual machine, right? And in that virtual machine, we will be installing the Ubuntu operating system. Okay, so in essence, what we will do, we will take the regular machine, the Windows-based machine or Mac-based machine, and we will be installing Ubuntu as the guest operating system. Okay, as a guest operating system. And when you go to Moodle page, so let me just log into the Moodle page. I think logged out. Just give me 1 second. So first of all, I request everyone to enroll to this Moodle page. I have already provided the enrollment key in the email which I had sent. And I hope everyone has enrolled in this Moodle page. If you have not, please do so as soon as possible, right? Okay, so far I see that 239 students have enrolled. Remaining needs to enroll to this page. So when you go to this page, basically, this is where I will be uploading all the lecture material, all the content, all the recorded sessions, all of them will be uploaded here. Okay, all the quizzes and lab assignments also will be uploaded here, right? So you will have to submit your quizzes and lab assignments also in Moodle, right? The final project version also will have to be uploaded here. So in short, for all the lecture content and all the submissions, we'll be using Moodle as our elements, right? So when you go to the course details, the file that I'm going through currently, that file has been uploaded in PDF format, which is your course detail file. And then you will see that there is a second PDF file over here, instruction for Ubuntu installation using virtual machine in VirtualBox, right? So when you look at this PDF file, it basically contains the instruction for installing Ubuntu on Windows-based machine. Okay, so if you are using a Windows machine, then you follow these steps, and when you follow these steps, you will be able to install Ubuntu on your Windows machine. So your Windows machine, Windows operating system is basically what we call host operating system, right? Because we are using a host machine, and using the virtual machine, you will be able to install the guest operating system as the Ubuntu operating system, right? So basically, you just have to go here and follow these steps. Now, I have shown the steps for 18.04 Ubuntu version. The current version is, I believe, 20.04, and I've followed the same steps on my laptop to install Ubuntu 20.04, and I didn't have any problem, right? So basically, you have to follow these steps, and hopefully you should be able to install the Ubuntu version on your machine. Now, even if you are using Ubuntu on your own laptop, you can still do the same thing. So in that case, what will happen is your host operating system will also be Ubuntu, and your guest operating system for the virtual machine will also be Ubuntu. If you are using Mac computer, also you can do the same thing, right? In that case, your host operating system will be Mac OS, and your guest operating system will be Ubuntu, right? So basically, these are the steps that you have to follow, okay, in order to do that. Now, one other thing, this is the VirtualBox website, and they have mentioned all the different guest operating systems that they support, right? And you can see that all of these guest operating system you can try out if you want to, but generally speaking, I mean, for now, we are basically going to be using the Ubuntu operating system here, right? So all of these operating system can be installed in the virtual machine if you use VirtualBox, which is the Oracle product, right? So that is all I wanted to show you here. So this is what we will be doing for the virtualization, right? Then the next thing that we need to learn is that, okay, now we have installed the guest operating system as Ubuntu, and we are able to, let's say, log into Ubuntu, and we write our code, right? We write programming in C. Now, how does that program gets converted from a C language, C program, to the executable code, right? So how does it go from source file all the way up to the executable code? So there are steps, there are compilation steps that are involved, right? So we will be learning that compilation steps. What are those steps? Next thing that we will go is into the operating system concepts, right? So then we will focus on the operating system concepts such as processes and threads. We know that today a lot of applications use multi-cores, right? On your laptop, you probably have 8 cores, 16 cores, 6 cores, 4 cores, whatever. So how is operating system able to take an advantage of those number of cores that you have? You know, how the applications are written using the multiple cores, right? So we will be using the concept of process and threads to do that, right? Now, whenever you have an application that uses process and threads, those application requires communication, and that is what we call inter-process communication, right? So we will also be learning how the communication between multiple processes happen. right, which are running on the same computer, right? So here we are talking about the processes or the applications running on the same computer, right? Then we also have the applications which are distributed, meaning that you have computers connected to the network, right? For example, we have, in our lab, we have all the computers connected to the same network. If you want to communicate between two computers which are connected to the network, how do you do that? Right? So that concept we also have to understand, and that is where the computer networks concepts will have to be understood. So I'll be covering theoretical aspects here also. So these are all the theory aspects that we will be covering. Now, once you understand these theory aspects, as I mentioned, the course provides you the actual practical implementation of the same, right? So we are not actually going to be just understanding the concept, but we are actually going to be implementing them. So to do that, obviously we will be writing some shell scripts which are going to be teaching you the Linux operating system commands, right? We will be also learning how to develop the libraries. I'm not sure if you are familiar with the term library. If you are not, don't worry about it right now. You know, when I cover the libraries, you will understand what it means. Then we will be writing the parallel application. So when I say parallel, meaning that the application which will be able to use multiple processors or multiple cores on the system that you have, right? On a laptop, on a server, whatever it is, right? So we will be using multi-process or multi-threading environment, and that is what we will be using. As I mentioned, we will also be performing the inter-process communication. Now, inter-process communication happens in two ways. One is called shared memory architecture, and the other one is called distributed memory architecture. So shared memory architecture is where you have a common memory, meaning your laptop, for example, has a single memory, right? A single memory device, but it has multiple cores. So you are running multiple processes or multiple threads in a single application, but it is sharing the same memory. So how do you do the communication between those processes or those threads? So that is what we study here. And then when you have an application which is spanned across the different computers, right? So the computers which are connected to the network, which is what we call distributed memory architecture, because the memory is distributed in different computers, right? So in the distributed memory architecture, we do need to do the communication also because the computers are connected to network, and that is where we will be learning the network programming, or what is also known as socket programming, right? So we'll be learning the socket program. So again, all of these aspects will be covered from the practical point of view. So I will be basically providing you snippets of code, and we will walk through that code, through the lectures, right? So these concepts will be taught theoretically, and then those concepts will also have the practical implementation of the same. Okay. Now here is the course, the lecture schedule and all the topics that we will be covering. And I have provided tentative number of lectures that we will take for each of the topics. If you have any questions about this, you can ask me now. Else we will, start with the introduction. Any questions from anyone? Okay. So then let me start with the introduction. All right. So what is system software, right? And important thing is, I always say that whenever you want to learn something or whenever you learn something, you need to know the reason behind why you are learning, right? So you should not be blindfolded and that say that, okay, everyone is learning this, so I will also learn. No, you have to understand the reason behind why you are learning this particular topic. Okay, so that is something that I am also going to cover in this particular introduction slide. So first of all, what we want to know is what is system software and why do we need to use it, right? So usually, when you talk about software or applications or programs, right? Whenever we talk about that, generally speaking, what we talk about is application programs, right? And what is an application program? So, for example, I'm talking about a bank website, right? Or a bank, Android application. Let's say if you have an account with a bank, ICICI Bank, HDFC Bank, they have an application where you can, do your transactions and things like that. Or let's say you are playing with, let's say you have an account with some stock, market service provider, right? And you are doing some transactions there, right? Or maybe you are buying groceries, right, through Big Basket or whatever, right? So all of these applications that we are using, right, they are called application programs, right, or user application programs. Why? Because these programs are meant to be used by end user, right? Are meant to be used by end user. So the web applications are not going to be actually used for maintaining the hardware on the system, right? Web applications are not meant for that, right? Or even the Android applications, if you use, they are not meant to actually maintain the hardware or interact with the hardware, right, directly. So that is why they are called application programs or end user application programs, right? What we are going to be learning in the system software is we want to write the software that actually helps us operate the hardware. Okay, so this is not the program that we are going to be writing that will be used by end user. So this is the software that actually sits in between the user application programs and the actual hardware, actual system that you deal with, right? So either we use the software to operate the hardware, or we interface with some component of operating system directly. If you do that, if you write a program to do something like that, then that is what we call system software or system programming. Okay. So as you can see, the second bullet point basically says that we are not providing the services to the end user, right? The system software does not provide services to the end user, but it provides the services to the application which are used by the end user. Okay, so if you want to run a web application, you need some hardware resources that are supposed to be managed, right? You need operating system, to manage the devices like keyboard, your drives, your network, USB ports. All of those devices has to be managed by someone. So when you write a software to manage all those things, that is where what we call system programming or system software. Why we need to learn, right? What is the need for that course? You can see the examples here. Okay, and I'll give you a few examples of my own also. I say that system software is all around us. Without system software, no device that we use today can function. A very simple example I'll give you. You're watching, let's say you may be watching TV every day. You have a set-top box. Now today's set-top box also are connected to the internet, right? They also have Android operating system, or maybe your TV is able to connect to the internet and it is able to get the program directly from there. It's able to play your YouTube channels and all those things. Now, obviously, so your TV has some network ports, and there's some connectivity required to the internet, and it requires some software that is able to grab the content from the internet, right? You are able to give the input through remote control, and that input has to be taken, has to be received by the TV, and it is able to take some correct actions based on those inputs. How it is able to do it? That is the software. That is what we call system software, right? The other example here that is given is operating system. So all the operating systems that we have is also in a way part of system software, because operating system is the first level of software that is used to manage your hardware resources, right? Your drives, your networks, your keyboard, your mouse, your display, everything, your compute resources, right? Your cores, processors, all of that, your memory, everything is managed by the operating system. And so that is the first level of system software that you have. There are a lot of device drivers that are also built into this operating system. If you're you may be playing games obviously on Xbox or PlayStation or whatever, right? Whatever. So each of these devices also require system software in terms of game engines, right? So it is supposed to have some sort of a firmware, some sort of a software which actually manages the joysticks and all the other control and sensing devices that it has, right? Industrial automation, everywhere again you will find system software being used. We use cloud every day, right? We use cloud every day. But do you know how the cloud infrastructure is maintained? How it is managed, right? So the point is, if you say infrastructure as a service, for example, IaaS, right? Infrastructure as a service, what does it mean? It means that, let's say, for example, I'm using Google Cloud, and today I ask for a resource which has 8 GB of memory, and I want, let's say, 16 core or 16 processor computer, right? So that is my resource requirement today. Okay, and Google Cloud gives me that. I can say that, let's say in May time frame, I require. Am I audible to everyone? Am I still audible to everyone? Can someone give me thumbs up? Okay, thank you, Aditya. Thank you. So, so basically, when we use the cloud, right? We say that we need this much compute resources, this much memory resources. But let's say in May, when we are processing the result, maybe that requirement increases, and maybe instead of 16 cores, we want 32 cores, and instead of 8 GB memory, we want 16 GB memory. And Google says, here it is, take it, right? How it is able to do it, right? If we are sitting on a computer which only has 16 processors or 16 cores, how Google is able to give me 32 cores? That means Google has some software that is maintaining the physical hardware, and it is giving me virtual hardware that says that all of this hardware, two of these machines together will be working together, and it will provide you 32 cores. So for me, it is 32 cores as a single machine. But for Google, it is two different servers. Both the servers, for the Google, it is two separate physical servers, but for me, it is single computer. I'm able to connect to that single computer where I can say that I get 32 cores and I get, X number of memory. So what I'm trying to say is that somebody has to write that software to maintain that infrastructure. Similarly, platform as a service where you need automatic installation of the operating system. So when you say platform as a service, what does it mean? It means that the operating system, drivers, everything is installed for you. Here, infrastructure as a service, you have to install everything yourself. Okay, so if you say platform as a service, somebody has to write a software that says that if you say that you want Ubuntu to be installed on that platform, Ubuntu will be automatically be deployed. It will be automatically be installed for you. Nobody is going to physically go and install Ubuntu. So no human interaction will be required, generally speaking. Okay, so this is the kind of services that can be provided if you are able to write the system software to manage that infrastructure. Okay, so whole of the cloud infrastructure that we are using, you require system software, system programming to be managing that infrastructure. Then only we will be able to use it. Right, now I move on to the buzzword that we hear a lot today, right, and that is called Internet of Things. Right, now what is an Internet of Things? So Internet of Things is nothing but that, still now we were able to connect the computers, laptops, desktops, servers to internet, to network. But now we have a lot of other smart devices, right? For example, as I mentioned, TV can be connected to the internet, right? Your set-top box can be connected to the internet. Mobile phones can be connected to the internet. These days, even the refrigerators and some of the air conditions also can be connected to the internet. Smart grids, right? If you have solar panels at home, you can install smart grid meters. What it means is that it can actually take the power consumption from the solar, and it feeds that data into the GEB grid. So GEB grid actually knows how much power you generated from your solar panels, and then when you use the electricity, they will deduct that many units from your bill, because that many units you generated, right? So again, smart grid, smart meters, you can use it for controlling or sort of like sensing air or quality control. This is a very big issue these days, right? Environment, we are polluting environment very badly, and air pollution control and water quality control is very, very important these days. So all of the IoT applications that you see do need some sort of a software, right? And that is again where the system software comes into the picture. So going to this slide again, basically some of the things I've already covered, but basically what is the difference between the application programs and system programs or system software is that system software focuses on the system, right? We are not focusing on a user. We are focusing on system. Whereas here, application software is going to be focusing on a end user. So banking application will figure out that how client will use your bank accounts, right? So how the transaction should happen and all that. Whereas here we are not dealing with such things. You require a detailed information about hardware and operating system. If you write system software, you need to know how your OS works, how your hardware is managing, right? You don't require that detail here, right? We are providing services to other software, right? In case of system software, we are not providing services to the end user, but we are providing services to other software. And you use the system software to program the hardware or interface with the operating system, as I mentioned earlier. Whereas here you provide the functionality for a user-specific application, right? The programming language here will be much different. You will be generally be using C++ or assembly language to program your system software, whereas here you will be using higher level languages such as C#, Java, Python, HTML, and many others, right? But generally speaking, here you will see that the languages will not change much. because C++ have been used since many years, and they still continue to use. The reason being that to implement the low-level functions, right, to deal with hardware, to deal with the operating system level stuff, you do need these languages. That's why. Okay. Uh, so a little bit more about IoT, again, because a lot of people use this word. So I thought I'll give you a little bit more information about that. So I have a couple of slides on that. So we know that Internet of Things has been used for quite some time now. So we are in 22, right? 2022, and so we are using about 40 billion devices which are connected to the internet. Okay, so about 40 billion devices are connected to the internet today. It is expected that by 2025 there will be about 75 billion devices that will be connected to the internet. And why that is? It's not because we are buying more mobile phones or more computers. It is because there are other devices such as refrigerator, TV, and many others, right? They will be connected to the internet, right? And that's why the number of devices will be increasing. So now when you have these newer kind of devices that you are connecting to the internet, then obviously you need some operating system or some software to operate that particular hardware, right? So as I said, TV, right? So TV has either Android operating system or maybe some customized software that is dealing to connect to the internet and grab the internet content and and cast it on the screen, right? Now every device obviously will have a communication interface also, right? So you either communicate through USB or HDMI or network port or whatever, right? So you do need to have the communication device on communication interface on each device, which also has to be programmed, right? Devices will have sensing units. So for example, our mobile phones, if you consider today, it has anywhere from 5 to 10, 12 sensing units, right? So you have gyroscopes, you have GPSs, you have fingerprint detection, you have a QR code scanner, and so on, right? You have a lot of sensing units. All of those also has to be programmed, right? So you require system software for that. Again, when you take the input from the sensing unit, you need to control something, right? So for example, if you are using an application to track how many miles did you run, right, or how many steps did you walk, or maybe you are checking your heart rate, right, on your smartwatch, right? How does it know, right? So there is a software that is running which is measuring something from the sensing unit, and that measurement is then converted into the actual units to be displayed, right? So in short, what I'm trying to say is that all of these things are required on IoT, and each of these things which are required requires system software. Okay, more applications I can talk about on and on and on, but this is the last slide that I'm covering, which basically again talks about how IoT is used in smart city. And again, these are some of the applications. I mean, there are many more applications that could be there. So there is an air pollution control, fire detection, water quality, smart parking, traffic congestion, waste management, and so on, right? So many smart city applications are there which uses this IoT, and each of these applications will require some sort of system software. Okay, so I hope I've convinced you that why do we need to learn this course, right? And again, as you can see that there are so many applications, and it will require so many different concepts, understanding from the software systems. And of course, understanding all the concepts, it's basically very huge. The course itself is very huge. So my goal here is to give you the foundation, right? So my goal is to give you the foundation. I give you the foundation and I give you the understanding of what this system software means, right? Now, if this topic intrigues you, if it creates an interest within you, you want to learn more about it, definitely, you can take additional topics, read it yourself or understanding. If you want to discuss things with me, you're welcome to do so. Okay. All right. So this is about, so till now what we studied is what is system software and why do we need to learn it. Now what I am going to cover is on which platform we are going to use it, right? On which platform we are going to learn this software. So I mentioned briefly earlier that we are going to use, Ubuntu operating system, right? But why do we choose to use Ubuntu or Unix based operating system, right? So if you look at this chart here, right, all the blocks that you see are different flavors of Unix based operating system, and each of these operating system may have a different applications, but in general, all of these are based on Unix, which is the base operating system. Okay, and the first version of the same was written in 1969. Okay, more than 50 years ago, right? And it is still being used and it is going strongly, right? So so you can see that that is the first version that was used in PDP-7, which was the very old computer, PDP-7. Which was in 1969, and then it went on and on. And I only have the chart till 2017, but even till 22 it continues, and it's very strongly being used. You know that Android, Mac OS, and all of those are flavors of Unix. And if you don't know, I have the next slide which will show you that. So Apple iOS, right? So some of you may be using Apple products or Apple, tablets or iPhones, which has Apple iOS, which is based on Darwin BSD. Darwin BSD is one of the flavor of Unix. Okay, BSD stands for Berkeley Standard Distribution, right? And this was the one of the Unix flavors. Okay. Mac OS is also based on Unix. Then we use Android phones, Android devices, Android operating system, Android TV maybe, right? Which is based on Linux. Okay, and Linux was built on top of Unix. Okay. Today, if you look at Android, it is supported not only on mobile phones and tablets, but Android is also supported by many computers also. For example, Digital Equipment Corporation Alpha servers, you can also install Android on that, right? Now DEC is, I think few years back it was acquired by HP, so now it is actually HP Alpha servers. Then you have ARM-based systems, small embedded boards that you may have, right? There also you can use the Android operating system, mobile phones, tablets. Then some of the Intel-based servers or desktops, laptops that we have, that also can have the Android operating system. There's a system called PowerPC, which was built by the alliance of Apple, IBM, and Motorola, which also use Android operating system. And then Sun Microsystems, which is now acquired by Oracle, which has a Spark computer, and this is also running on the Android-based operating system, or can run on Android-based operating system. PlayStation OS, right? PlayStation has an operating system of its own, which also runs on FreeBSD. FreeBSD again is the Unix flavor from the Berkeley University. Ubuntu is based on Linux. Linux is based on Unix again, and I believe that there is a new operating system. There's some research going on in the area of cloud operating system. So you know that when you have a single laptop, single computer, you install Windows or Linux or Ubuntu or Android or whatever. But then managing the cloud infrastructure, right? Instead of having different operating system to be installed on different servers, if there is a single operating system that can manage all the hardware resources underneath, right? That will be very helpful. And I think that there is some research going on in that area. And this operating system is also going to be built based on the Unix-based flavors, right? So what I'm trying to say is, again, why we are learning Ubuntu is because Ubuntu is based on Linux, Linux is based on Unix, and lots of Unix flavors are being used in the in the industry today, right? So that is one of the reasons we have to we are kind of using that. So any questions so far from anyone? Okay. Yes, someone has question. Yes, Chandra Prakash, you have a question. Okay, fine. Thought you had a question. Okay. So if you don't have a question, please put yourself on mute. All right. So now what I'm going to talk about is the or if you have questions, you can maybe put it in the chat so that I can see it. Because I think there are many students are not able to see the Achha, you cannot unmute yourself. Okay. So okay. So I'll change the. I think I may have to change the settings so that you can unmute yourself. And before the next lecture, I'll try to do that. There are a couple of questions in the chat, so let me take a look at that. What do P1, P2 mean in the section of course outcome? So basically, there was a file provided to us which basically says, and I think I can share that with you. So basically, it's a program outcome. Right, so the program outcome basically says that what the graduate will learn, right? So P1 means that engineering knowledge will be gained, right? P2 means problem analysis will be able to do. P3 means design and development of solutions. So basically this, I believe that this probably would have been shared with you by Dean. So this was shared to us by Dean. So that is what we were supposed to use it here. Okay. But I mean, I don't think you really have to worry about that one. Some of us didn't receive the enrollment key for the Moodle. Okay. So what I will do is I will paste the enrollment key here in the chat so that you can take you can use that. So it is IT215SS as the enrollment key. Okay. That is the enrollment key. Okay, so answer, I gave it in the wrong chat, but let me just put it again. Enrollment key is IT215SS. Right? Okay. Then can you explain why we are using Ubuntu again? if we install Ubuntu in Windows machine, then we will, which will be the host OS. Okay. So, so host OS is always going to be the Windows machine, right? Or Windows. So when you say host, what it means is primary operating system, which is already there on your computer, right? It is called host operating system, right? Whichever operating system you installed in the virtual machine is what is called a guest operating system. So Ubuntu will be the guest operating system, and Windows will be the host operating system. If you install Ubuntu in, as a virtual machine in the virtual box, right, in the machine which originally has the Windows operating system. Okay. Why we are using Ubuntu is because it is a flavor of Unix. Okay. Ubuntu we are using because it is a flavor of Unix, and so this one, right? So Ubuntu is based on Linux, and Linux is basically Unix-like. So when you say Unix-like, meaning that originally they took the original version of Unix and then they build Linux on top of that, right? So major functionality of that you will see in the Ubuntu. So basically what happened was Unix was not graphical, Unix did not have a graphical user interface. Okay, Unix did not have a graphical user interface, meaning that you had to do everything on the command line. So instead of doing that, in the Linux, they expanded the functionality of the Unix, plus they added the graphical user interface. So you can do many of the things by click, right, by the mouse click. And then in the Ubuntu, again, they further expanded the functionality of the Linux, which is what we call Ubuntu. So in short, all these operating system is primarily based on Unix, and we want to learn the operating system which is Unix like or Unix based, because in the industry most of the embedded systems, most of the servers, all of these uses Unix based operating system. Personal computers are always generally using the Windows operating system, but the corporate servers, right, they generally use Unix based operating system. Hope that answers your question, Subham. Any other question from anyone? Someone is unmute. Can you mute yourself, please? Or if you have any questions, ask me. Shubham, do you have any questions? Shubham, are you there? Can you hear me? Not sure. Okay. So let me move on to the next slide. Yes. Yes, Shubham, do you have a question? Okay. So the next slide is about the basic Unix Linux architecture. So primarily what happens is that, when we talk about any system, right, when we talk about any system, whether it is, still not here. can you mute yourself? Harsh, can you mute yourself? Harsh Buddhadev. Okay, so whenever we look at any system, we have the hardware, right? And to operate the hardware, right, we need some layer of software on top of it. Okay, and that layer basically is what is called kernel, and kernel is heart of operating system. So whenever we say operating system, the main component, the most important component of the operating system is what we call kernel. Okay, so kernel is responsible to interact with the hardware, and it is supposed to perform different tasks like memory management. Meaning, let's say for example you have 8 GB memory, which application will use how much memory? Who will decide that, right? And which block of memory will be, memory is divided into certain parts, so which block of the memory will be used by which application, right? That is the function of memory management module, which is within the operating system, and it's part of kernel, right? Then you have the process, which is basically your application. You have threads, you have tasks. All of these are the application components which are running. How do you ensure that which of the CPU, which of the core will be running which of these threads, which of these processes, right? So how do you determine that scheduling part? How do you manage files? How do you manage your network resources? For example, there is one network port on your computer, and there are 10 applications which wants to communicate through that network port. Who will use that network port at what time? How does that manage? How it is managed, right? It is managed through some component of operating system. So what I'm trying to say is that all of the hardware that we have requires some sort of software to manage the hardware, right? And that is what we call kernel. Now, the outermost layer that you see here is what we have is the application programs. Now, application programs can be a web page, can be a mail, can be a database, can be the application which uploads, download files, which is what we call FTP, right? So many applications could be using different parts of the computer, right? Different devices on the computer. But how do the application program gets an access to the hardware through kernel, right? So application program does not directly have an access to the hardware. Application program has to go through the kernel, right? So there are two ways to access the kernel from the application program. One is shell, right? One is called shell. So shell is basically the command line interface. It is a command line interface to run certain operating system commands or kernel commands to get an access to certain resources, certain hardware resources. Second way is that there are some special functions in the kernel which is what is called system calls. Okay, so we use system calls, which are the special functions within the kernel through which you can also access the kernel code and the hardware resources, right? So basically this middle part, the center part, this white one, right, it contains the shell and some of the system calls that the operating system allows us to access from the application program, right? And that is what we can use to communicate between the application program and the hardware. So this is the architecture of the very high level architecture, right? So there is a lot of things over here. This is just a very basic architecture of the operating system that we generally see, especially the Unix Linux one. So let me stop here. I think it's around 1:15. So I'll stop here because I want to continue the remaining part of the content, which is now covering the actually Unix and Linux basics, or Ubuntu, whatever you want to call, operating system basics. So I'll start covering that from the next lecture. But if you have any questions, I can take them now. Anyone? Any questions? Let me look at QA. Do we have to recall the concepts of computer hardware? Well, so basically what you have to know, Shubham, is that what is the organization of the computer, right? That is the subject that you have studied, I believe. So you should know that, obviously what is memory, if you know what are cache, if you know what are cores, if you have some understanding of how the operating system runs on the computer, that might be good. But if you don't understand that, don't worry, I will cover that in the, in brief, right, during the lecture. How can we make OS or our required system for a particular application like car system? Well, I think Chirag Chawda, I'll tell you that in car, in modern car, you don't have one computer. There are more than 200 computers in a single car these days. So if you look at like BMWs or some fancy cars, all of the things that are controlled, right, has a computer. So for example, even the tire pressure is controlled by the car's computer. It will basically sense that what is the pressure in the tire, and if the pressure is low, then it will basically indicate on its monitor, right? If you have a low petrol or low gas, right, that will also be communicated. Brake system, health of the brake system will be communicated. Health of the security system, the health of the fluids, right? All the fluids